Reciprocal substitution. So reciprocal substitution says that if the limit as x approaches infinity of 1 over x is also the same as the limit as x approaches 0 from the right of x. Now it's called reciprocal substitution because the limit of 1 over infinity is equal to 0. And I put that in quotations because 1 over infinity is a really, really small fraction where we can call that 0. So if we replace the infinity with a 0 from the right, then what we do is we replace the 1 over x with the reciprocal of that, which is just x. This also works with negative infinity, but instead of looking 0 from the right, we're going to look at 0 from the left. So I'm going to show you kind of why this works and graphically how to represent it. So if we look at the graph of 1 over x, as we approach infinity, the limit as x approaches infinity of 1 over x is 0. Now if I look at the reciprocal of that, the limit as x approaches 0 from the right of 1 over x is also 0. Now let's look at the limit from negative infinity. So as we approach negative infinity, the limit as x approaches negative infinity of 1 over x is also 0. And as we approach 0 from the left, you get that the limit as x approaches 0 from the left of x is 0. My mistake, this should be an x right here, not a 1 over x. So you take the reciprocal of infinity, which is 0, and then you take the reciprocal of the function, and you'll get the same limit. So example 9. We want to determine the limit as x approaches infinity of sine of 1 over x. By just looking at this function, I really don't know what's going on, because 1, I'm approaching infinity, which is way out to the right, and sine of 1 over x is a kind of tricky function to think about. So we know that as x approaches infinity, 1 over x approaches 0. So by using reciprocal substitution, we get that the limit as x approaches infinity of sine of 1 over x is equal to the limit as x approaches 0 from the right of sine, and then the reciprocal of 1 over x is x. Well, now we know what sine of x looks like, and we know the limit as x approaches 0 from the right, so here's sine of x, and we know the limit from the right is going to be 0, so this should be 0. Let's look at the graph. So this is the graph of y equals sine of 1 over x. Now as we get towards 0, we don't know really what happens, but we want to look at the limit as x approaches infinity. So as you approach infinity, you see it starts to tail off. But then we use reciprocal substitution, where here is y is equal to sine of x, and we see that as we approach 0 from the right, we get 0. So based off this piece of information here, and this piece of information right here, we can note that the limit as x approaches infinity of sine of 1 over x is equal to 0. So now on your own, I want you to try to determine the limit as x approaches infinity of x times e to the x, and the limit as x approaches negative infinity of x times e to the x. Alright, here we go. So again, using reciprocal substitution, because my gut says that this piece is going to be infinity. Mostly because it's going to be infinity times infinity, which should be infinity, but we don't know that for sure, so we have to check it out. So then the limit as x approaches infinity of x times e to the x is equal to the limit as x approaches 0 from the right, and then every time we see an x, we're going to do reciprocals. So 1 over x times e to the 1 over x equals, and I don't know, we're going to look at a graph in a minute, But let's write out the next one. The limit as x approaches negative infinity of x times e to the x is equal to the limit as x approaches 0 from the left of 1 over x times e to the 1 over x. Now what makes this really nice, even if I don't know what this is, I can go ahead and look at the graph at the behavior at 0. Looking at the behavior at infinity is much more difficult. So here's the graph of our reciprocal. So this is y is equal to 1 over x times e to the 1 over x. So the limit as x approaches 0 from the right, which is this piece, we can see is shooting up towards infinity. And then the limit as x approaches 0 from the left, we can see approaches 0. So then based off our reciprocal substitution, we get that the limit from the right is infinity and the limit from the left is 0. So the limit as x approaches infinity of x times e to the x is infinity, and as you approach negative infinity, you get 0. So the big hit here is to look at the graphs.